Alright, this is Unit 7, Lesson 3 of our calculus class. Unit 7 is Applications of Integration. Lesson 3 is Area Between the Curves, Round 2. So we're going to continue our third of 4 lessons on, or what will be 4 lessons on finding the area between two curves. In this lesson we're going to focus on how do you handle integration or area between two curves if the curves intersect at some point in the middle of your interval. So basically something like this. So I know that it's the top curve minus the bottom curve, but what if the top curve, if they intersect in the middle, what's on top and what's on bottom changes partway through. So we're gonna handle that by splitting our integral into two pieces. So from A to B, B being the intersection point, A being the beginning of our interval, and C being the end point of our interval. If I take from A to B, the area between the two curves, well, f of x is the top function and g of x is the bottom function. But from B to C, g of x is the top function and f of x is the bottom function. So how I'm going to handle that is I'm just going to find the area between the two curves of each from A to B, and the area between the two curves from C to B to C, and I'm just going to add them together. So the region in total is equal to the area underneath the curve from A to B of f of x minus g of x, again top minus bottom curve, and then I'm going to add the area under the curve from the interval B to C of g of x minus f of x, which in this case is top curve minus bottom curve. And that's how we handle that. You just split into integrals, which, if you think about it, is not saying a whole, nothing mind-blowing there, right? You just cut it in half, find each piece, add them together at the end, you're good to go. So right here we have an example. We have a region that's kind of two pieces. It's bound by x equals 0 and x equals 1.25, and somewhere in the middle they intersect. And so to find the intersection point, I'm going to set our f of x and g of x equal to each other, and it's a little bit nastier of a quadratic, but we can still use quad formula. And I did use my calculator a little bit to get this 28.25. That's totally okay. And then we get two answers, so negative 3.5 over 4 minus our square root would give us one answer, and plus our square root would give us another answer. I noticed that if I do the former, if I do minus our square root, we get a negative 2, which is outside of our interval that we're integrating for. And so I know that when I take negative 3.5 over 4 plus our square root, it gives me, my calculator tells me, it gives me a 0.454. And so that's got to be our b value. That's got to be the x value on which our two graphs intersect. So when I integrate this thing, my middle b value is going to be just that, 0.454. So I'm going to go from a to b of top function minus bottom function. And from a to b here, if I call a 0, b is at 0.454. My f of x is on top, and my g of x is on bottom. So I'll go f of x minus g of x here. We're going to add the other region. So from b to c, g of x is on top, f of x on bottom, so we'll do g of x minus f of x here. That's our setup. Now I'm going to plug in our numbers. So a is 0, b for both of these is 0.454. f of x minus g of x would look like this. G of x minus f of x would look like that. If we simplify each of those, we get a simplified quadratic, and they look somewhat similar but slightly different because we're subtracting one versus the other. Yeah, and so I can type these into my calculator. Let's try that out just for funsies. So let's see here. Clear this. Clear. Okay, so I'm going to type in this first bit in my calculator, and then I'm going to put plus this second bit and see if I get 2.506. So I'm going to put this right here. I'm going to make our window like this so I can see my calculations. Alright, in the last video I used the standard view for showing how to do the calculator, the function integration. This one I'm going to use the normal math print for the newer calculators. So to integrate on a calculator, you press math, then you press 9, and that pulls up function integration. Our first interval is from 0 to 0.454. Our function is negative 2x squared. And when you're doing this, the calculator does know the difference between negative and subtraction. Our negative button's down here, our subtraction button's up here. If you do not use those appropriately, you're going to confuse your calculator. It's going to give you a wrong answer. So just don't forget that. Alright, here's our first integral. I'm just going to press plus. I'm going to press math 9 again. And we're going to put our second integral. That's from 0.454 to 1.25. To 1.25. And our function is 2x squared plus 3.5x minus 2. And we're integrating with respect to x. Press enter. There's your 2.506, rounded of course. I think the homework wants you to round to the third decimal place value, so in this case we round down to 506. And that's it. That's that one. Good to go on that. Alright, so the lesson here, we got more confidence integrating to find area between curves. This case, what's new is our graphs intersect halfway through, so we just have to make our calculation is a sum of two integrals, since the top curve and the bottom curve are different on different sections of our interval. But that's it, nothing else new here. Still using our calculator because we got these nasty decimal answers. But we're not afraid of that, are we?